All right, good afternoon, everyone. This is Mr. Pere, and I want to have our chemistry class now. Now, without wasting time, the topic we want to consider this afternoon is oxygen. As we know, oxygen is one of the very vital substances we must use as human beings before we can survive. So, oxygen is the topic we are considering this afternoon. Now, we have the following objectives. At the end of the class, you should be able to do the following. Very important. You should be able to describe where oxygen is located on the periodic table. You should be able to tell us the group, the period, and the block oxygen belongs on the periodic table. Number two, you should be able to describe the laboratory preparation of oxygen. How do you prepare oxygen in the lab? You should be able to tell us that. You should be able to explain after watching this, after this class. Number three, you should be able to describe how oxygen is prepared in the industry, in large scale. How is oxygen prepared? Then number four, you should be able to state the properties, both the physical and the chemical properties of oxygen. Then if time permits, we can still go ahead and talk about oxides, the different types of oxides, tests for oxygen gas, and uses of oxygen. So these are the things we must cover at the end of discussion of this topic. Now, where is oxygen located in the periodic table? Well, before then, do you know that oxygen is the most abundant element on Earth? And the air we are breathing in contains 21% of oxygen. That is hilarious. That is to let you know how important oxygen is. It was first discovered by Chile in the year 1772, and he named it oxygen, meaning acid producer. That name was given by Lavoisier anyway. It was suggested by Lavoisier, acid producer. That was because it was believed that all acids contain oxygen. However, with time, it was discovered that that statement was not correct, but the name oxygen was still valid, was still given to it. Now, where is oxygen located in the periodic table? From the electronic configuration, you can see that the last electron enters p orbital. That is to let you know that oxygen is a p block element. You know, we have four blocks in the periodic table: S block, P block, D block, and F block. So oxygen is in P block, and that is because the last electron in the electronic configuration of oxygen enters P orbital. That is why oxygen is in P block. Now, if you want to consider the group and the period that a particular element belongs, you need to convert this shell notation to orbital notation. And in doing that, what you normally do is to make sure that when you see one, that means the first shell contains two electrons. And when you see two, that is to let you know that the second shell contains a total of 2 plus 4, which is 6 electrons. So since the second shell contains 6 electrons, oxygen is in group 6. While it has only 2 shells, therefore it is in period 2. So that is how we determine the group oxygen belongs. So oxygen is group 2, group 6 element, and it is in period 2. Let's go for another important thing we need to discuss about oxygen. How do we prepare oxygen in the laboratory? How is it prepared in the laboratory? We have different compounds that we use. Different compounds. The first one is potassium triiodochloride 5. You can see the formula here, KClO3. And we heat it in the presence of manganese 4 oxide catalyst. And anytime this is done, this is the equation for the reaction. It will break down to give you potassium chloride and oxygen gas. So in this case, manganese 4 oxide is acting as a catalyst. So this is one of the methods of preparing oxygen in the laboratory. Another method is from hydrogen peroxide. You know, originally hydrogen peroxide breaks down on its own inside the container to produce water and oxygen gas. But to increase the rate of this reaction, we still add a catalyst, which is also manganese 4 oxide. And when this manganese peroxide is added, the rate of decomposition of hydrogen peroxide becomes very fast. And then it will break down to give us water and oxygen. This is the second method of preparing oxygen in the lab. Then the third method is by decomposition of nitrates. Nitrates are those compounds that have NO3 in their formula. For instance, this is NaNO3. This is sodium nitrate. We can have CaNO3, which is potassium nitrate. All nitrates, when you heat them, will always break down to release oxygen gas. So from the equation, you can see that sodium nitrate, when heated, give us sodium dioxynitrate 3, and then it gives us oxygen gas. So these are the three main methods we use to prepare oxygen in the laboratory. Now let's go for the industry. How do you prepare oxygen in large scale? How is it prepared in the industry? Number one, through the electrolysis of acidified water. The apparatus used in carrying out this reaction is called Huffman voltammeters. Huffman voltammeters. Now, you have done electrolysis before. Electrolysis is all about the use of electricity to break down a chemical compound, to break down an ionic compound. Don't forget, it must be ionic, not covalent compound. It must be ionic compound. Now, in this process, we add few drops of concentrated H2SO4 into water, and that is the process of acidifying the water. The reason why we add the acid is because water is a very weak electrolyte, so it ionizes partially. So when we increase the conductance, that is the ability to allow electric currents to pass through it, we do that by adding a strong electrolyte, particularly conc H2SO4. When this is carried out, you know that hydrogen being positive ion, hydrogen ion being positive, will migrate to the cathode and it will discharge. And then hydroxide ion, which is negative ion, will migrate to the anode and it will discharge in form of oxygen. So automatically, oxygen is liberated at the anode during the electrolysis of acidified water, while hydrogen is liberated at the cathode. You already know this. Now, apart from electrolysis of acidified water, the second method used in preparing oxygen gas in the industry in large scale is fractional distillation of liquid air. This method involves two main processes. The first one is liquefaction of the air. And in this process, they are trying to convert the gaseous air to liquid air. That is the first method and the first process. And how do they carry it out? They allow the gaseous air to pass through a compressor at a very low temperature, which is actually minus 200 degrees Celsius, and a very high pressure, which is 200 atm. When they carry out this liquefaction process, the temperature, which is minus 200 degrees Celsius, is very low. Therefore, the liquid air is formed. The gaseous air gets converted to liquid air at that very low temperature. That is the first process. The second process involved in this fractional distillation of liquid air is that they will put the liquid air into a fractional distillating setup and they supply heat. When the temperature is increased to minus 183 degrees Celsius, from that minus 200, it is increased to minus 183 degrees Celsius. The boiling point of liquid oxygen is minus 183 degrees Celsius. So it will boil and be collected as liquid air. It will first boil, the vapor will get to the condenser, and then the condenser will convert it back to liquid, and liquid air will be collected. So those are the three methods, the two methods used in the industry to prepare oxygen gas. The first one I said is electrolysis of acidified water, where oxygen will be collected at the anode. Then the second one is fractional distillation of liquid air. And I said this process involves two main stages. The first one is liquefaction of the air, which is carried out using a compressor at minus 200 degrees Celsius and 200 atm. And the second stage is the fractional distillation of the liquid air that was obtained. So those are the two processes used in the industry to prepare oxygen gas. Now, let's consider the properties of oxygen, physical properties of oxygen. Now, number one, just like hydrogen, just like chlorine, oxygen is also a diatomic molecule. Diatomic simply means that two atoms of it combine together to form a molecule of it. So oxygen is a diatomic molecule. Number two, just like water vapor, oxygen is a colorless gas. It is odorless and it has no taste. So those are some of the physical properties of oxygen. Then apart from those ones, do you know that oxygen does not have effect on litmus paper? It cannot turn blue litmus paper red. It cannot turn red litmus paper blue. Therefore, oxygen is a neutral gas. It is neutral to moist litmus paper. Then oxygen is slightly soluble in water. Slightly, to a very large extent, it is soluble in water. And this is why animals can stay in the water without coming out of the water for a long time, because some oxygen has dissolved in the water, which the animals in the water can actually make use of. Apart from that, gaseous oxygen is denser than air. It is 1.1 times denser, so it is heavier than air. Then finally, on the physical properties of oxygen, it liquefies at minus 183 degrees Celsius. And when you further lower the temperature, it becomes a solid at minus 225 degrees Celsius. So these are the physical properties of oxygen. Now let's run through the chemical properties because our time is going so fast. Chemical properties simply means the chemical reactions a particular substance can undergo. In this case, we want to consider the chemical reactions oxygen can undergo. Number one, reaction with hydrocarbons to form oxide of carbon and water vapor. Anytime you are burning an hydrocarbon, it is actually reacting with oxygen. And depending on the amount of oxygen present, if we have excess supply of oxygen, carbon dioxide and water vapor are formed. But if we have limited supply of oxygen, if the amount of oxygen available is just little, then we are going to have carbon dioxide and water vapor. And it is very simple, but please don't be confused over that. Always, when you want to balance it, always balance the carbon atoms. For instance, look at this one. This is butane burning, reacting with oxygen to form CO2 and water vapor. If you want to balance it, this is carbon atom. You come to the back of the oxide of carbon and you put 4, because here it is 4. And then this is hydrogen atom, 10 atoms. So you come to the back of the water molecule, you put 5, so that 5 times 2 will give you the 10. When you want to balance oxygen, you always consider the right-hand side before coming to the reactant side. At the right-hand side, we have 4 times 2, which is 8. Then 5 times 1, which is 5. So 8 plus 5 will give us 13. So whatever you have over 2, that is why we have 13 over 2 for oxygen here. So that is how you write the equation for the burning or for the reaction of hydrocarbon with oxygen to give oxide of carbon and water vapor. Another important chemical behavior, chemical reaction of oxygen is reaction with metals and non-metals. Oxygen is just so unique that it can react with both metals and non-metals to form what we call oxides. By definition, an oxide is a chemical compound made up of only oxygen and any other element. So for instance, look at the first equation given. Oxygen combined with magnesium to give us magnesium oxide. Magnesium is a metal, while oxygen is a non-metal to form magnesium oxide, which is ionic compound. Then we have sulfur, which is a non-metal, reacting with oxygen to form sulfur oxide. So you can see that oxygen has that ability of reacting with both metals and. All right, you are welcome back. I think the system logged me out. Let's see how we can rush to finish up this work. Okay, so we're talking about chemical properties of oxygen. So the last one I said is the reaction between oxygen and hydrogen to form water. This is a very common reaction and it is very violent. Anytime heat is supplied, they explode and the water vapor is produced. That is why a mixture of hydrogen and oxygen can be used as fuel, because they will bond to release large amounts of heat energy. So those are the few chemical reactions of oxygen we are considering. Please, in case you have questions, you are free to ask your question. Now, one other thing we want to consider is oxide. What is an oxide? From what I've told you before, an oxide is a binary compound. That is a compound that has only two elements, and one of the two elements is actually oxygen atom. And we have four main classes of oxides. We have acidic oxides, which are actually oxides of non-metals. That is, when oxygen reacts with a non-metal, it forms acidic oxide. They are called acidic oxide because they dissolve in water to form acid. An example is the reaction between carbon 4 oxide and water to form triisocarbonate 4 acid. So since they dissolve in water to form acid, they are called acidic oxides. Then we also have basic oxides. Those ones, they dissolve in water to form basic solutions. And they actually oxides of metals, like the magnesium oxide we're talking about. And one important thing is that they can actually act as bases by reacting with acid to form salt and water only. So that is about acidic oxide and basic oxides. Then we have amphoteric oxides. These ones, they are oxides of metals like zinc 2 oxide, lead 2 oxide, aluminum oxide. However, they can react with both acid and bases to form salt and water. That is why they are called amphoteric. Amphoteric means ability to behave like an acid, ability to behave like a base. So you can see the equation where zinc 2 oxide is acting as a base by reacting with an acid, and you can see the second one where it is acting as an acid by reacting with a base. Then the last class of oxide is neutral oxides. These oxides, they are the opposite of amphoteric oxides. They do not have acidic property, they do not have basic properties. They are just neutral. They are neither acidic, they are neither basic. An example is water vapor, which is H2O, carbon 2 oxide, and laughing gas, N2O. All these ones are examples of neutral oxides. Then how do we test for oxygen gas? How do we test for oxygen gas? For instance, we said oxygen is a colorless gas, but it is not the only colorless gas. If you are given a container that contains a particular gas, maybe a test tube that contains a particular gas, how can you prove that that gas is oxygen gas? What you need to do is to insert a burning wooden splint. A wooden splint is just a very flat kind of stick. Set it ablaze and then introduce it into the container that contains the gas. If the gas is oxygen gas, then it will rekindle. That is, the wooden splint will burn more brightly. But if it is any other gas, it will not do that. However, there is one gas that behaves like oxygen by rekindling wooden splint. It is laughing gas, which has the formula N2O, nitrogen 1 oxide. Now, to separate between nitrogen 1 oxide and oxygen gas, we use nitrogen 2 oxide, that is NO. If you add NO to that unknown gas that rekindles a burning wooden splint, if it gives you a reddish brown film, that is a reddish brown gas, that means that unknown gas is actually oxygen gas. Laughing gas does not give any reaction when you treat it with nitrogen 2 oxide. So that is how we test for oxygen gas. It rekindles a burning wooden splint. What are the uses of oxygen? Number one, just like any other animal, oxygen is used for respiration by man. All other animals also use oxygen, so for respiration. Then number two, oxygen is used, it is combined with other substances like hydrogen, and then they are burned. When you burn them, they release heat, and this heat is used for melting and cutting of metals. That is why welders normally make use of a mixture of oxygen and hydrogen, or a mixture of oxygen and acetylene as their fuel, which they will burn, and they will use the heat to melt or to cut metals. Then liquid oxygen is used as a fuel in rockets science in moving rockets. Liquid oxygen is used as fuel. Then oxygen is also used to remove impurities. If you have something like pyrites, iron pyrites, that is FES, you can normally burn it with oxygen to release sulfur dioxide and iron will be left behind. So impurities like sulfur can be removed using oxygen. And then finally, oxygen is used to prepare very important chemicals, particularly acids like tetrasulfate 6 acid, triazonitrate 5 acid, ethanoic acid, and so on and so forth. And that is where we are going to draw the curtain. But before then, now you have these questions to answer. Please just solve these questions and return back your answers to me as reply to this discussion. Thank you. Have a nice day. If you have questions, you can forward your questions to me. But after then, please solve these problems and send back your answers to me. All right. I wish you a very blissful day. Thank you. Thank you. Thank you for listening. And have a nice day. Bye bye.